In this video, I am going to take a bunch of derivatives using the general power rule. So the general power rule looks like this. If we have a function, which is another function raised to a power, then the derivative of this function is we bring the exponent down times g of x to the n minus 1 times the derivative of this inner function, so g prime of x. Okay, so here is our function. The inner function here is x squared plus 2. We're taking that to the power 3. So the derivative of this function is 3 times x squared plus 2 to the 3 minus 1, which is 2, times the derivative of the inside function, which is 2x. And so that gives us 6x x squared plus 2 squared. The second function, we probably should rewrite it to make it a little easier. So it's g of x equals 3 minus x squared to the power 1/2. And that gives us a derivative. Bring the exponent down, 1/2. 3 minus x squared to the 1/2 minus 1, so that's negative 1/2, times derivative of the inside function. Derivative of 3 is 0. The derivative of minus x squared is minus 2x. And so that is equal to, the 2's cancel, we've got a minus x over the square root of 3 minus x squared. Finally, this function here, this is the kind of thing that would show up in calculations of, this is a future value, right? Interest rate of 4%, continuously compounded. This is the future value at time t of $10,000 invested. So I need to rewrite this so this looks like something to the power n. So I'm going to rewrite this h of t equals 10,000 times e to the t to the 0.04. So that's sort of our n. And that gives us h prime, the derivative is 10,000, that's just a constant, times 0.04 e to the t to the power 0.04 minus 1 times derivative of the inside function here, this e to the t is just e to the t. And now what we can recognize is we're multiplying e to the t to 1 power times e to the t to the first. And so that's going to be, let's see, multiply this out, 400 e to the t to the 0.04 minus 1 plus 1, which of course is 400 e to the t to the power 0.04, which is 400 e to the 0.04 t. Once we have the chain rule, we'll have a slightly easier way to calculate that derivative.